Alright guys, so welcome back. This is the second example that we're going to do right now, and I already drew my circuit. I have my resistors, I have my I1, I2, I3, and I have these are called nodal voltages, which basically means it's just the voltage at a node. So the first thing I want to do, I'm going to label my sign convention for the resistors. So I'm going to follow wherever the current go, the direction that we did in previous videos. We're just going to stick to it. So here I'm going to label this plus minus, plus minus, plus minus, plus minus. Another step that I'm going to do is label my ground. So my ground is basically the node or the point where I have 0 voltage. So I'm going to choose it as at the bottom. So this whole node has a voltage VG which equals 0. And this is really important, and you're going to see why in a bit. So they're asking, they want us to find I1, I2, I3, and V2 and V4. So basically the first thing we have to look at is what we're given. How can we make use of what we're given in this question? So the first thing is we have a voltage source right here. And how can I make use of it? So I'm going to label this V1. And if this is V1 and this is equal to 0 volts, so V1 minus VG should equal my voltage source, which equals 15 volts, which is given right to me. So VG is equal to 0 as we agreed before. So this means that V1 equals 15 volts. We just applied the definition of a potential difference or voltage source right there. Now, I'm going to write this on the side that V1 equals 15 volts. Now, how can I make use of this? So, let me just get this out of the way. So, for me to find, if you look at this point right here, it kind of reminds me with KCL, right? So we say that apply KCL at V2. So the total current in equals the total current out. So this means that I1 equals I2 plus I3. So far, all it is just apply KCL. Well, I don't know I1, I2, or I3. But I know V1. So I'm gonna try rewriting this equation in a way where I can make use of finding V1 and knowing the resistor values. So we're gonna use Ohm's law. If you remember, before we wrote if a resistor is between points A and points B, so the voltage drop across the resistor, it has a value R and it has a current I passing through it. So if we have this case, we can say that the voltage drop across the resistor, which equals to VA minus VB, or the voltage at point A minus the voltage at point B, it's just the difference between these two, equals to the current passing through the resistor times the resistance of the resistor. So keep this in mind. Now, if we want to relate this to node 2 to this equation that we have right here, I'm going to call it equation 1. I'm going to relate I1 to the voltage that we have. So I can rewrite this as I equals to V over R. And now let me rewrite each one of these currents in terms of a voltage and a resistance, because I know one of the voltages, I know V1, and I know the resistor values. So let me try to do that right now. Let me cut this part off. So now I1 equals to, it goes from V1 to V2. So it's V1 minus V2 over 6 kilo ohms. And I2 equals, it goes from V2 to ground. So V2 minus 0 over 9 kilo ohms. And then I3 equals, it goes from V2 to ground again. The current doesn't just stop here. Don't let this V4 fool you, okay? It's just, I can name whatever node I want. The current I3, it follows this path, right? So it goes from V2 all the way to ground. So I can write that I3 equals V2 minus 0 over, on its path, it goes through two resistors, and they're in series, so obviously I can add 9 plus 9 kilo ohms. Now, I'm gonna sub the value of I1, I2, and I3 with these values, because if you notice, I have nothing unknown in these three terms but V1, because but V2. I calculated V1. That's why it's useful. That's why they gave us the value of the voltage source. So now that I have V1, I can just solve for V2. So let me just sub in. So V1, let me just rewrite this equation. I1 equals I2 plus I3. So in other words, I can, instead of I1, I can write V1 minus V2 over 6K equals V2 over 9K plus V2 over 18K. And I know the value of V1 is 15 volts, so V1 is equal to 15 volts. So now solve for V2. This should be a piece of cake. You guys are engineers, you know how to do that. So now that I found the value of V2, I still need to find the currents in V4. So looking at this expression, at any one of these expressions, I can easily find the branch currents, because I have V1 in, if I look at I1, I know the value of V1, and I just calculated the value of V2, so I can find I1. Same thing with I2, I have the value of V2. Same thing with I3, I have the value for V2. So I can just, instead of going back to the circuit and looking at it and just kind of confusing myself, I can just write, this is a reminder, so remember that I1 equals V1 minus V2 over 6. Also remember that you have the value of V1 and you calculated V2, so you can write 15 minus V2 over 6, and then you guys do the math, and it's just as easy as that. But just remember, because your resistance is in kilo ohms and your voltage is in volts, your answer is going to be in milliamps. Just a trick that you guys might get I'm stuttering too much today. Just a mistake. That's where you guys might fuck up, and that's where the professor's that's where most students lose their marks. Same thing with I2. You can write V2 minus 0 over 9. So V2 minus 0 over 9K equals, V2, it's over 9. It's going to be something in milliamps. Same thing with I3. Instead of 9, you have 18 here, and then you found out I3. So now that I found all the branch currents like a fucking G, how am I going to find V4? That's a good question. So if you look at, so I want to find V4, so this is the part of the circuit that I give a shit about right now. So let me just erase all this mess, because it's really annoying. Oh god. So I'm going to redraw this part of the circuit. Let me just cut it out. Oh shit, never mind. Oh my bad. Okay, so I'm just gonna redraw it. You have this resistor, and I3 is still flowing through here. This is ground. You have a 9K, and you have V4. How do you find V4? If you can't tell that you need to use Ohm's law, just drop out. It's as simple as that. So V4 minus VG should equal to the current I3 times 9 kilo ohms. So VG is 0. I know I3. So you literally just solve for V4. So it's equal to 9 I3. And it's going to be in volts, because this is in kilo ohms, this is in milliamps. So kilo times milli, this is 10 to the third ohms, and this is 10 to the negative 3 amps. So they cancel out, and it's ohms and amps, which gives you voltage. So if you guys have any questions,